In this video we'll be programming the MPA. In the last video we made a simulation for it, and now it's time to make some kind of useful program for it. So we'll head straight into using the standardized blocks from the Norsok I005 standard. It's a bit overkill for our simple simulator. It's still this one, the MPA. But we need to control 3 binary pumps and read some sensors. So the first thing we're going to do is control these 3 pumps. They will be controlled in exactly the same way, all 3 of them. But we would like to add modes to it. By that I mean you have the outside mode, where you have some kind of remote controller somewhere close to the pump, and some manual control from an HMI screen, so you can turn it on and off from an HMI screen, and an automatic mode, so it can be controlled by some other kind of PLC logic. That's 3 modes that we'd like to have. All 3 of them are included in the template blocks that we're going to use. The blocks are already made, so we'll just drag and drop and configure them. So let's see what we have here. This is a text version of the main program. I'll still like to use continuous function chart just for the graphical part of it. Hopefully it will be easier to follow than using text. Let's add that one to the PLC task. So we'll need the pumps, which are binary equipment. You can switch them on and off, and yes, we have a block for that. Switch binary electric, used for binary on-off control. So let's use that one. Let's call this object pump1. Let's initialize the parameter struct. Let's give it a name, so which is used for display pump1. Startup settings. This window doesn't really show what that means, so we'll have to come back to that one. Don't remember what it was. But I'm gonna guess 0 is the option for starting the pump in manual mode and off, and 1 is manual and running, which means the startup is when you turn on the PLC, or similar if it's restarted. Mode options should be which modes are available, and I'm not sure which option says all 3 of them. So let's figure these 2 out first. Here are some delays. If you don't get the feedback that it's actually running when you want it to run, within 2 seconds there's an alarm. And if you lose the feedback, there's an alarm after 2 seconds. And you have some pulsed outputs. If you want to use those, you can say how long those are going to be pulsed. And if you want something to happen, if there's an external fault or you lose the enable signal, you're not going to use the enable signal now, or if you lose the feedback, what should happen you can define here. There's 2 options. And there's a restart option, and you restart the PLC for some reason. Let's find some more info on startup setting and mode options. Let's look at the DUTs for this one. So we chose 0, which is manual and run. That's the one we want. Then the template is in manual, and No, wait, we want manual and stop, sorry. We want the pumps in manual and we don't want them to start. We want them to stop as default when we start. And mode options, outside manual and automatic, that one's correct, 0. 1 was only manual and automatic. We want all of them, so startup settings should be 0, manual and run, and mode options should be 1. That should do it. So startup setting 0, already forgot. 0 and 1. 0 and 1. Hopefully these pins will look familiar. In the last part we imported all the I/O tags. You'll see pump 1 confirmed running feedback. It's all indexed by pump 1 and then some kind of name, X, XGH, LO, XOH and so on. Those are named to fit with these pins. So the object is pump 1. Let's find the output. So pump 1 Y connects here. Pump 1 Y goes to pump 1 Y, and so on. So let's connect all of those. Let's see what we have. We have the binary confirmed high and low going to the remote controller. The binary signal for outside mode is also going to the remote controller. So let's add those. Pump 1, binary confirmed high. And low. And status for outside mode, so we can turn on a light when the local remote is the one controlling everything. That's the wrong pin. So there we go. And then the XGH, we have that one. These pins are used by other logics. If the template is in auto mode, you can use these pins to turn it on and off. Here's the outside mode pins, those we do have. Really need to get a new chair because this one is obviously squeaking. Sorry for that. We don't have these two, we should have. This is external fault, so an example of that will be something's wrong with the I/O card connected to some of these signals, then there's a fault and this template should know about it. And maybe stop or start or whatever. And this one, we should also have a separate, maybe a switch for the pumps, so that the supply voltage, if the supply voltage is actually supplied, then this one is true. So if you have a relay with a binary feedback, this one should be connected there. So you don't try to turn off or on pumps that's never going to be turned on. And you can indicate it on the HMI display that it's not enabled, so you know where to go to fix the problem. LO, the command from the local remote to lock the template in outside mode. We have that one as well. These bits is for when the PLC is starting up, when it is restarting. We actually have those. I've combined them all into one separate function block. The reason for that is that these kind of signals vary from manufacturer to manufacturer. So I don't really want to make different blocks for different vendors, so I made this block, and if this one will work on TwinCat, but it won't work on Siemens. Well, we're gonna look inside it. But then again, that's all of it. So I edit this one only. So I don't need to edit my SPE template, I just need to edit this comment template to get the scan time and whatnot. So I've collected all of the known stuff that's different from TwinCut to Siemens and just moved it into here. So this one I'll find from... We'll see, it's hard to see the pop-up menus. And that's because this, or I don't really know why, but it's connected to using Windows 10. So if you have a computer with Windows 7, don't upgrade it if you want to work with Visual Studio and TwinCut, or Siemens for that matter. You don't have official support for it, but the Siemens TIA portal does work in Windows 10, but it's not officially supported. So if you have Windows 7, don't upgrade if you're working with these kind of PLCs. That should do it. And we can remove all the pins that we're not using. Tidy up. Oops. That's pump 1. And let's do the same for 2 and 3, if I can be able to copy paste this. We need to declare pump 2 and 3. More or less the same kind of pumps, different names. Update those. And then all the input pins. This would be way faster if we were using text, and we could just find replace. But continuous function chart still, it's graphical, and this program is going to be small, so I use it for illustration purposes. Another good thing about using text is when transferring from TwinCut to Siemens, it's easy to copy paste. Again, copy pasting. And then making it fit into TIA portal isn't that much work at all. Especially if you've avoided some common differences that you already know of. So you can always copy paste straight in. And in this example, where we use the common block from my library, most of the edits are done in the common block. There's not really any edits in the other templates. There we go, all 3 pumps with all kinds of modes and error handling and whatnot, all ready to go. So this should work straight out of the box. Now we'll need to add some kind of visualization. So we have some buttons to push. Let's just say yes to whatever it wants. I like the background to be as gray as and boring as possible, so 192, 192, 192 RGB colors should fit to minimize the glare. If you have sun coming through the window or some lighting condition that's making your screen glare, just try and keep your colors gray to minimize that. So let's see what we have here. In our library we have a SBE. Let's use that one. It looks like this, and we have 3 of them. That's 3. Let's tidy up. And these need to know what template to connect to. So let's find the statuses from pump 1. Those are called operator station statuses, or OS star. Similarly, OS commands and all the parameters. Pump 2. Feel free to use these blocks for any project work you want to do. It might seem difficult to use. There is a threshold for getting started, but keep in mind that these are as good, if not better, than any blocks you'll find. And they're free. I'm not going to charge you anything for it. But if you want to mess around and make crappy code, I'll totally understand that as well. That's one way to learn. So why not? Now that we've mapped all of them, pump 2, 1, 3, we should be able to turn it on and off. But we have nothing to look at except feedback that it's running. Well, let's just see if that works, just for the fun of it. Definitely need to add something to look at. So, Untitled 1, green and green, and SimPLC is not running, so let's download the SimPLC, start that one as well. And these are all disabled, which makes sense. It's probably hard to guess, but they do need to be enabled, and the default enable value is false. So we don't have an enable value, I mentioned this earlier, like binary feedback from the relay to the power supply to the pumps or something like that. But even though it's not available, we do need to initialize it. So let's enable the pumps. There we go. Now they're enabled. All of them are off. High is turning it on, low is turning it off. So let's try and turn it on. It worked. Seems okay. In the options here we have the binary feedback. We turn it on, that's our command, turn on. And we received the feedback, and it worked. But what's going on now, we really have no clue. So we might be emptying the tank, and when the tank is empty, the pumps are pumping air, and pumping air is not a good idea. It's probably going to ruin the pumps. Let's see what's going on here. Yeah, we're pumping air. It's empty. So we shouldn't do that. So we could add some kind of visualization to show the sensors somewhat like this. But how about we just use this signal, that if this signal is low, the water level is too low, so we should stop the pumps. We should force them to stop. Let's see here. So let's find that signal. That was level switch low 1x. This one should stop all the pumps. Also, I'd like to add some kind of alarm to it. So there's a template for that. Monitoring of binary. There we go. Call that ls low 1. That's the object. Give it a name. And here we can invert it. We can invert it outside as well. So in this case, let's do it inside. Latch. Would like to keep it true if it has been true. So you actually have to manually confirm for it to go off again. And I'd like it to not give an alarm before it's gone past, let's say, 100 milliseconds. Not that many pins. The X goes to LSL1X. And the Y here. That's when there's an alarm. We can block the alarm straight from the template, but let's use this alarm to stop all the pumps. So let's figure out what pin we should connect to. Yeah, go into the library, find the SPE. So what can we use? See, lock safeguarding low, overrule, locks template to manual, and off regardless. Yeah, so let's use that one. So let's connect the alarm to LSL, lock safeguarding low to turn off the pumps and keep the pumps in manual. We need to expand. Let's make some room here. Find the LSL pin. That's the one here. Connect that one there. And then remove unused. Let's move that one down here. Keep this one at the top corner. Really doesn't want to. Oh, okay. Let's tidy up. There we go. Maybe something like this. Find the LSL. And tidy up. LSL. Sorry about that. And we're back. Let's finish up this part. Something like that. Let's see if we can get it to do straight lines. There we go. So if this one is false, inverted to true, then LSL pins will be true and the pumps will stop if the tank is empty. So let's see what we have in our tanks. It's all empty. And this one is closed. And there's some water in the top one. Now let's log in and download this. Oh, one more thing. Let's do auto enabling. Let's set this one to true, so we don't need to do that again. These are all still the same, hopefully. Let's see if this works. Then maybe need to reset. Let's see. So these are all low. We're not able to turn them on. Let's see here. We have a safeguarding, which is the LSL pin. We can block it. Now there's a conflict there. Yeah, safeguarding is blocked. And then we're able to turn it on. But then we're forcing it to run dry. That's not a good idea. Maybe we need to for some reason. Maybe the alarm is wrong or whatever. But if we enable the alarm, we're not allowed to stop if there's too little liquid. Let's add a template for the LSL MB. See if we can find one. See how this one looks. Yeah, good enough. And then map it. That's the LSL1. And the commands. And the parameters. Then login. Yeah, so here's an alarm. We can try and reset it. That's not working. We can block it. It's still latched, so it's not off. It's still there. So you can see. Oh, sorry. If we remove the blocking, the latch value will go through. So we blocked the alarm. There's no alarm, but the cause of the alarm is still there. So all the pumps are off. Let's open up the manual valve. See, the declaration here is gone, so I need to open and close. Close and open, sorry. Fully opened. Now those are true. It's still latched. Take the blocking off, then the latch value goes through. But now this button has effect. Now I reset the latch value, but there's no the origin of the alarm is gone. So when I reset the latch value, it's actually reset and not set again, and it's all good. So now we're allowed to start the pumps. And then almost no change. It's all just going straight through. So let's close the valve a bit. Oh, now it's empty. That emptied fast. All the pumps went off. There's an alarm. And now it's filling again slowly, so we should be able to see, yeah, the cause of the alarm is gone. So when we reset it now, the alarm is gone, and we can start again. That went fast. Let's try and run this one. There's the alarm, and it goes off. You can reset it and start again. And there's the alarm. Reset it. And now we basically program the basic function of the 3 pumps. We can turn it off and on from the HMI screen. We can also go into outside mode. Or obviously not. Mode options 1. Which means yeah, that's the incorrect one. We need mode option 0. Let's correct that. Let's just do it the right way. Mode option. And the same. Let's see if we now have the option of turning it into outside mode. Yes, we do. So now all the pumps are in outside mode, which means that these buttons don't work. They're not supposed to. Let's reset the alarm. Now we're supposed to control it from the local remote. And let's do a very simple simulation of that. Let's find pump 1. We don't need to lock it in outside mode manually because we've already done it from the screen. So we have all of these statuses. Outside mode is on, this is true. We already have those. All of them are off. But now let's use these. Command high. Oops. And pump 2 and 3. So when we write these values, we'll use the outside mode option, or the outside mode control, to turn on pump 1, 2 and 3. Let's see if that works. Now. It didn't. I'm on the wrong one. Let's try now. There's the one. And it all went off again when the alarm became through. When the alarm goes off, there's still a outside command to turn it on. So it tries to turn on. So this here is indicating someone holding the button down on turn pump on the local remote. Oops, wrong one. Let's use the simulator. There we go. So we've tested outside mode and manual mode. So that is the manual mode, the buttons on the screen, and the outside mode, the buttons on the controller, remote controller next to the pumps. And we tested the alarm with the safeguarding. So you have the basic function down. You're not allowed to run the pumps dry, and you can control it from the screen and from the local remote. And the next part will be programming the 3 pumps as primary, secondary and backup. Which means that if the primary fails, the secondary should start, and if the secondary also fails, the backup pump should also, or emergency pump should start. So that's how to program the MPA.